Good morning, Fancy Meat Computers! How's everybody doing today? As Yash points out, you are all beautiful people, for showing up to this class, which is obviously your favorite class this semester. I don't want to go out on a limb or anything, but I'm pretty sure this is your favorite class this semester. So I want to announce an exciting new initiative from the Mr. Nicholas Moore Lecture Hour. If you guys have suggestions for intro songs, I will take those by email. You can't put them in the chat here because you can't post links in the chat here. But there are some rules. 1, purely instrumental, no lyrics. 2, has to be royalty-free music. Has to be royalty-free music. So if you are bored at any point over the weekend or whatever, and you're like, you know what, I want my music to be in the intro music for this amazing class I'm taking, just email it to me. I would prefer the link to be like in the form of a link to a royalty-free music website so that I can verify that it's actually royalty-free. But there you go. You may have input. Ha ha. Redo your 2EO4 lab for the 3rd time in 2 days. That is gross. That is just gross. That is no good. All right. So. All right, let's do this. I think the only announcement is that I posted the link to MS Teams. So the MS Teams link is there, but I think I did that previously, so I won't dwell on it. That's for any of you who are taking the virtual tutorial. So I'll say it once more. The intention is that if you are able to come to a in-person tutorial, that you will come to an in-person tutorial. This will be good practice for next semester when hypothetically everything will be in person. So, please only use the virtual tutorial if you need the virtual tutorial, because space is not limited in that it's virtual, but, the more people there are in the tutorial, the less time each person gets. So, it would maximize your tutorial experience to spread yourselves out a little bit. Anyway. So, last time we were talking about Linux and stuff. And we'll continue talking about Linux. For the rest of this, we're basically going to be talking about Git. So, for those of you who are, paying attention to things, you will have noticed that there is an expectation in this course that you will use Git as a submission vehicle for submitting your assignments. We're going to be using GitLab, the department's GitLab server, rather than GitHub. Most of you, if you have used Git before, have probably encountered GitHub at some point. The GitLab is, like, the permissions system is less atrocious, and it's, you get a GitLab account free with your CAS registration. So there you go. Y'all should have GitHub accounts. So there you go. Are you talking about my class saying something's due on September 19th? Because I don't believe that to be the case, but we can check. I was intending on releasing assignment 1 next week, so probably. Yeah, look. Sorry. That is so tiny. Zoom. There we go. Maybe. There we go. So, assignment 1 will be released in the week of September 19th, which is next week. and will be due October 4th, which is, or the October 4th is a Monday. I should modify that and make it the Sunday. I think I might move the due date up a little bit there, just to make it in line with everything else. Yeah, that's all Mondays for some reason. Very strange. November is correct, though. Slight oversight. So, anyway. Yeah. No, that's the time that the assignment is released. The other column indicates when the assignment is due, and the assignment is due on the October 4th due date. If I go to the home page in Mectron 2 MP3, it says A1 is due September 19th. Does it now? Like, in the assignments? Like, what are we talking here? Oh. Well, that's QEF, quite easily fixed. The due date is not the 19th, it is the 3rd. Save and close. Ta-da! I must have made that mistake while I was, yeah. I must have made that mistake while I was setting up that Dropbox. Although I'm not sure why there is even a Dropbox, because we expect the submissions to come through GitLab, so why do we even have an assignment Dropbox? Yeah, okay. The assignment Dropbox no longer exists, and therefore the conflicting due date also no longer exists. There you go. Yes. So, this whole exercise is one in which I am supreme leader, and what I say goes. So if I say that the due date is this day or not that other day, you can take that to the bank, because I am the dictator of due dates. But yeah, no, thanks for checking that, and sorry about the confusion. Yeah, I haven't even released assignment 1, so how could I expect it to be due? That doesn't even make any gosh darn sense. Assignment 1 won't be that bad, by the way. But anyway, so, version control. So, we were previously talking about various problems that have to do with software development. In particular, it's difficult to manage code projects which have a lot of people working on them. Avery says, I am the danger, I am the one who knocks. Yeah. So, version control systems manage changes to source code and related files in repositories, or colloquially, repos. You will hear me call it repo because repository is way too many syllables. Repositories make it very straightforward to keep your files up to date with latest changes. Whenever changes are committed to the repo, a new version of the files is created. Developers can access old or alternative versions of the files, so detrimental changes can be reversed. Repos are important in the open source community as they can be used to manage crowdsourcing coding projects. So, very basically, a version control system is a file archive. It's a way of archiving things, but it's an archive that distributes itself across a network. Most of the time, using a kind of a client-server setup. But Git is interesting because it's actually a point-to-point setup rather than a client-server setup. Although, like, if you're using GitHub, GitHub is going to be the server. But yeah, so Git Git is the one that we're going to talk about, but there are more different types of version control than just Git. There's also SVN is the next most popular. After that, you have Mercurial. But you can tell that in general, over time, Git has basically completely overtaken version control systems and is now like, as a person who has used both SVN and Git, Git is overwhelmingly superior, so there's a reason that Git is winning. So, Git was created in 2005 by Linus Torvalds. That's right, folks, the Linux guy. Linus Torvalds, you may remember, wrote the Linux kernel in 1991 at the University of Helsinki. And he also wrote a program called Git. He named it Git because it's British slang for an unpleasant person. He got called a Git quite a lot during coding projects, so he decided to name the it's kind of anti-Git software, but it's called Git. Yes, as in Linus Tech Tips. Possibly. No, not CVS, the pharmacy. But yeah, so yeah, I was looking for a photo of him, and I found this one, and I'm like, I can't not put that in the slides. So, today, the most popular way to obtain a Git repository is through the internet service GitHub, but we'll be using the department's GitLab server for this class. Previously, you had to pay for a subscription for private repositories, but since being bought out by Microsoft, private repositories are free. It just got cut off there on my slide. I apologize. I should fix that. So, this is the way that... So, having a software archive is really, really useful, because what it means is that you can it works very similarly to like a checkpoint recovery system for your operating system, right? Your operating system has things that are kind of similar to a repository system built into it so that you can roll back your operating system in case you get the viruses. It's kind of like that, but a small one that's just for like a specific folder in your file system. Previous version control systems followed the traditional client-server model. Git uses a distributed model. So traditionally, the server has like the master archive, and all of the clients interact with it. In a more distributed setup, each client has its own independent repository, and they are synchronized with each other whenever, a synchronization event occurs. This makes it a little bit more like Bitcoin, to be honest. It works, blockchain, well, this came before blockchain, so blockchain kind of works like this, but, In practical terms, a server will still be necessary to coordinate the distributed clients. So you have all of these clients, but, a server somewhere has to, have the latest changes queued up so that the each client can go to, one location in the internet to find the latest changes. But yeah. So, getting started. Even if GitLab is hosting your repository, you will still need the software installed if you don't want to do everything in a web browser, which is probably, you probably don't want everything to happen in a web browser. So, if you want to download Git, you can get it from https://git-scm.com/downloads. Whoop. Boink. There we go. So you can get it from Mac, Windows, and Linux. If you're already running Linux, some distros will already come with Git, some will not. It's simple enough to install. You can also get Git with Git, so that's kind of fun. Can I explain Bitcoin and what it is and mining and stuff if it relates to our class or at some point, something at some point? Ask me again after class and I'll tell you what Bitcoin mining is. At least my paltry understanding of it. So, yes. So you can download it. In general, GUIs are fine to use, but command line is usually faster and can be integrated into scripts, etc. A professional software developer is expected to understand how to use the command line version. Yes, Ubuntu comes with Git, but Mint does not. It was kind of interesting. There was like a whole bunch of stuff that I expected Mint to come with, and Mint came with basically nothing. I had to install a lot of stuff by hand, which, you know, is fine, because it means I have a bunch of junk that I don't have to worry about on my computer. Or not, there's a bunch of junk that I don't have to worry about because it's not on my computer. An older version of Git is probably fine, but to update it, you would do something like sudo apt update, and then like your package manager should manage the updates for you, but like updates for Git are few and far between. So when I say integrate it into a script, we're going to do shell scripts in a tutorial in a week or two. But this is a shell script. What a shell script is it's basically an arrangement of command line instructions that you can put in a file and execute sequentially. So this file navigates to each folder. Like, I keep all of my course materials inside of Git repositories. They're synced up to GitHub, but yeah. So Git repositories for all. Like, I keep all of my stuff in there because it makes it easy to collaborate with my TAs when they need course materials. All I have to do is give them the link to the give them permissions on GitHub to access my private, my private repositories, because of course, there's stuff in here that I don't want you guys seeing, like the drafts for the test and stuff like that. But yeah, so all of these commands automatically sync all of my repositories with the server. So all I have to do is type git sync, which is my little script, and it checks to make sure that all of my repositories are up to date, and if they're not up to date, they fetch any changes and push any changes, and everything is cool and wonderful and works very well. These are all the courses I teach, by the way. So that's remote Git repositories. It's also possible to have a local Git repository that is not synchronized with an external server. Let me just pull up a terminal right here and maybe zoom in a little bit. Zoom, 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 zoom. There we go. So, Git init. Well, you make the directory first. So make directory example repo. Navigate into it. So cd example repo. And then git init. Initializing empty Git repository in this repository. There you go. Yeah, sure. No. Nope, that's a privilege that's exclusively reserved for TAs, being able to peek at the test. So, so I now have a Git repository inside of this folder. You can't see anything, but you can if you look at hidden folders. So what that does is it creates a hidden folder inside of the repository called .git, which contains all of the information that it contains all the archival information that's necessary to maintain a Git repository. Yes. Also, pushing things into Git means you don't have to worry about losing the files. Yes. So that's the other thing, is that it's a very, very valuable backup strategy. So it's actually a little bit like cloud storage. A little bit like cloud storage. Maybe you'll become a TA. Okay, but not until you're finished the course. So hot. I've never had a TA for a course who was taking the course at the same time, for good reason. So yeah, that's another huge advantage of Git. I think that on GitHub, they if you're using the free version of GitHub, you're not allowed to upload any particular file that's greater than 50 megabytes or something like that. But so long as all of your files are under 50 megabytes, you can just store as much information in it as you could possibly want. So yeah, it's a really good backup strategy as well. Absolutely. So, files and folders with the dot prefix are hidden files. You can view them with LSA. Git workflow. Here are some general procedures for working in a repository. These are applications. These are applicable to other version control systems as well. So, here are your basic workflows. When you're in a repo, files and directories are either tracked or untracked. Only tracked files and folders are a part of the repository. Files and folders must be added to the repository manually. Fortunately, you can do it all at once. So, in general, this is how it works. Let's say you had a file. Let's get it example.txt. I am the very model of a modern major general. Save that up. So, with a call to git status, you can see a list of the files which are tracked and untracked, and the changes which are queued up for committing, right? So, okay. So, a commit is committing something to the repository. That means you're making one of those archival timestamps, right? It's the same process as making a snapshot of your operating system. You're making a snapshot of the files inside of the repository. And those snapshots can be shared over a network if you're using a non-local Git repository. So you can see right now my untracked files are example.txt. So if I want to add it, I either type git add example.txt if I want to specify one file, or git add dot in Linux means the current folder, and that adds that to the tracked files. Now if I call git status, you'll see on branch master, no commits yet, changes to be committed, new file, example.txt. If I want to actually commit this, you type git commit. Normally, you also include the M flag and provide a commit message. Commit messages are very, very, very important. Commit messages tell you, commit messages are intended to be a, they're intended to tell other people and yourself what changes were made during this commit. So in this case, it would be added file example.txt. There we go. So now example.txt is in there, right? So if I take a look at the git log, you can see that I have one commit here, right? It has a commit ID, and it tells me what my commit message was. If I make a modification to the file, so if I get it, or you know what, nano example.txt, if I add something to it, if I say I am the very model of a modern major general, I've information vegetable, animal, and mineral. Save that up and exit. And then if I get, why can't I type? There we go. For some reason, I guess the old process was still running. So if I do git status, you can see I've got changes not staged for commit. I have modified example.txt. If I type git add git status, you'll see the modifications have been staged for commit, and git commit added to example.txt. There we go. I can now take a look at the git log, and I have two commits in there. One in which I added the file, and one in which I added to the file. So this is the most recent commit. This is the second most recent commit. I'll answer your question when I'm finished with this demonstration. So so one of the cool things about Git is that you can roll back to previous checkpoints, right? You can roll back to previous commits. So if I believe it's git checkout, and then I provide it the ID number for the commit that I want to check out. Note, switching to that I am detached head state. Yes, yes, yes. If you want to create a new branch, we're not going to worry about branches just yet. So if I take a look, now that I'm in this detached state, I am now looking back in time. Cat example.txt, I hope this works. There you go. Ha! So you can see I have reverted the changes that I've made to example.txt by looking back previously in the archive. And you might say, well, this seems like a lot of work just to be able to have a fancy undo button. But, you know, undo buttons are very useful. And undo buttons over an entire file system can be especially useful. So this is like one of the very big advantages of Git repositories. So, now that we have concluded that demonstration, so you don't really understand what Git actually is. So Git is a program which manages archives, right? We call them repositories because we like to be fancy, but Git is to a folder in your file system the same as a operating system snapshot is to your operating system. So you know that, like, with Windows, you can set it up so that it takes a snapshot of your system like every couple of days or so, and then if you have a virus or some other catastrophic failure from the blue screen of death these days, you can roll the system back to a previous state before the error occurred. This allows you to do the same thing, but with just with an individual folder in your file system, not the entire operating system. It also allows you to network these archives with other users across the internet, and it's a really effective way to be able to collaborate on coding projects. So that is what Git is, what it's useful for, what it does. So basic git commands. I'll go through this quickly because I just gave the demonstration. We're not going to... Oh, did I actually finish this? No, I didn't. Here are some general procedures for working in a repository. These are applicable to other version control systems as well, although the details are slightly different. In a repo, files and directories are either tracked or untracked. Only tracked files and folders are a part of the repository. Files and folders must be added manually to the repository. As you work on files, periodically commit your changes to the repository. You can think of this as super saving your work. So the idea is, as you're working on something, as you're working on a project, you make commits every once in a while. Like, break for lunch, make a commit. You know, end of the workday, make a commit. Somebody requires your attention elsewhere, just commit that. Commit that shit. If you're working on a networked Git repository, which is probable, something like GitLab or GitHub, these are networked Git repositories, you also have to push your commitment to the network. Doing this every time you commit is a very good idea. So git push synchronizes your archive with the network. So, you know, if I were to, you know what? I'll make a GitHub. Well, I'll make a GitLab repo for you guys, and you can see what that looks like as well. But we'll do this basic stuff. We'll do that when we get to networked stuff in a couple of slides. So, we're not talking about server uploads or downloads just yet. Just commands operational on local repositories, such as the one that I showed you. So, git add, file name, tells Git to track the specified files and or folders. You can add multiple files as well. You can use glob patterns to target all .c files. But if you do git add dot, that will get everything in this directory and everything in every subdirectory. Git commit with a log message m commits everything in the working directory and all subdirectories. Commits expect a log message, which can be specified using the m flag. If you fail to provide one, Git will open up a text editor like Dano, because you probably just forgot, right? Descriptive log messages are important. Important like good commenting habits. So, insofar as commenting your code well is important, providing meaningful log messages is also important. So, don't be this guy. Created main loop and timing control, enabled config file parsing, MISC bug fixes, code additions, edits, more code, here have code, blah, 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 blah. My hands are typing words, hands. As projects drag on, my git commit messages get less and less informative. Don't be this guy. So, git status. Here's some useful commands as well. Git status displays which files are and are not being tracked, which files have changed since the last commit, and what the current working branch is. We're going to get into branches. Git log displays the date, time, and author of commits on the current branch. Also displays commit IDs, ID numbers, and lovely log messages. So, for example, one of the other course, so in this one, this is the course materials repository for this course. Git status, or git log. Let's see what the log looks like. So you can see there a few of the TAs have been making commits to this repository as well, which is good. But it's mostly me. But, that's because, well, I don't know. There's a fair amount of TA activity going on in there. But yeah. So it's just a really useful way to permission to flex a little. Yeah, go for it. Permission granted. Git log one line graph. No? one line. Oh, yeah, I need to actually be in the Git repo, don't I? So 3mi3, which is another course I'm teaching. One of my TAs actually knows how to use Git very well, and has been opening up branches. So you'll see these are this is one-line summaries of all of the commits, and you can see that in Git you can kind of peel off a version, work on that version, and then merge that back into the main repository so that you can work on a feature without interrupting other people's work on their parts of a project. But we're going to get to branches. But that's what Git log can show you. Git checkout changes your tracked files to the specified commit or branch. You can use this to undo changes and to just navigate the repository. So, one of your colleagues says, on my summer co-op job, I had to use Git to push test case automation to the company's GitHub. It was mildly annoying, but directly applicable to what we're doing in this class. Yes. Yes. So, if you tried pushing to a repository and the repository told you that you do not have locally changes that have been made to the repository, then you have to use git pull. You git pull the changes, and then you can push. That's one of the things that's nice about Git, is that it forces you to get the updates before you can make changes to the repo. So this is how commits will look if you don't have any branches. In Git, the master is the default branch created with the repository. So, some people are calling this main these days, but if we git log, git revert head, head, there we go. There we go. Cat example.txt. What? Really? Git log. Git checkout head. Let's see. Oh, okay. Git checkout master? Yeah, okay. Cat example. There we go. All right, we're back to master. So, git log. So you can see this is the head and on the master branch. So master branch is just the central branch that all other branches branch off of and back into, hopefully. Head is the most recent commit on a particular branch. So you should always pull before working on files that are in a repo. Yes, 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 yes. Can I do the, yes, clap, you, clap, should, clap emojis? Are you allowed to use something like source tree for Git management? Because it's a bit vague doing it from the command line. Okay, I will disagree. It is not vague doing it from the command line. You just need to know the commands. But yes, if you want to use a GUI to manage Git, then and you know how to do so, you're perfectly welcome to. I'm just doing it from the command line because you should know how to do this from a command line as a software person, as a person who knows software. I know you guys are Tron people, but yeah. Anyway. So, the head of the branch is just the most recent commit. Checking out a branch automatically takes you to the head of that branch. So, what's the point of this again? All the foregoing repository management stuff is great and all, but likely overkill for many tasks. It's more applicable than you think. Any project of significant size would benefit from this approach. However, where things really come alive is your ability to network your repositories. I'm going to do an internet. So, if you want to network your repositories, the first thing you have to do is set one up. So, let's bloop. Let's see, gitlab.castmaster.ca. So, you have to provide your login, but So, we're going to make a tutorial document. So, in GitLab, to make a repository, you click New Project. Well, that's kind of the advantage of having this recorded, isn't it? So, you create a blank project. You call it example project, or whatever it is that you want to call it. Right? You can choose the URL for it, but I'll just put it in mine for now. You can set its level of privacy. So if it's private, then you have to invite people to be able to get it. If it's not private, then people can just download your code. So when you make your repositories to be able to submit your work to us, they have to be private, or else that's an academic dishonesty charge. Because if they're public, then you're essentially sharing your code with everyone, which is a big no-no. Big no-no. So, create project. So here is my new blank project. In order to get a local copy of it, I clone with HTTPS. There we go. Copy the URL. Go back to my command line. Get out of this directory, make, and yeah. So when you clone something, it'll make a new directory. So git clone, paste the URL, enter, and there we go. It's already, if you haven't done this before from GitLab, it'll prompt you for your credentials, which, you just provide your CAS username and password and everything's cool. So yeah, example project. Let me just copy in, for example, hello.c into example project. There we go. Go into example project. There we go. And you can see I've got hello C in there, and it's not academic dishonesty. I'm being part of the Stack Overflow community. Wrong! It's academic dishonesty. Ha! I am the professorial dictatorial power over what is or is not. Well, that's not actually true. It's I am an interpreter of the university's policy on academic dishonesty. So what I think about what is or isn't academic dishonesty definitely counts. Just so you know. So I have now hello.c in here. You'll notice that readme was a file that was made here, right? That's a file that was made inside here by default, and it showed up when I cloned the repository. So if I git add and git commit added hello.c and git push, and then I reload this page, you'll see that hello.c is now in my Git repository, my GitLab repository. Ta-da! And if you invite the TAs and myself as collaborators on this repository, then we can download your solutions to the assignments in the same manner. If I copy a C file over, do I have to recompile it? Well, I didn't copy the executable, I just copied the source code, so anybody who wanted to use the source code would have to compile it, yes. But I could copy over the executable, but generally speaking, you want to try to avoid copying executables around. Like, the executable has been built for my system and my system's hardware, so whether or not it would work on your system is, completely up to the winds of fate and chance. But yeah, so there you go. And you can edit this, right? I can edit this, maybe take out this stupid comment, right? Preview changes, commit changes. There we go. So you can make a commit here, right? And now if I git pull, you can see that something happened. 1 file change, 7 deletions. And cat hello.c, you can see that in this, in the C file now, the modifications that I made over here have been made over there. So the important thing to realize about this is that these modifications that I'm making, it's kind of a little bit facile, I guess, because it looks like I'm just modifying the same location on my own machine. But no, it's like this GitLab repo is sitting on the department's server, right? And I am basically, I pushed changes, I popped them up to the department's server. The department's server, I then requested those same changes from the command line, and it pulled those changes and put them in the left hand, in my actual file system. So the important thing about this is that these changes can come from anyone, right? Oh, what does cat do? It just displays the contents of a file. So when I cat hello.c, that displays the contents of the file. I could also open it up and get it or something, but yeah. So, yes. So yeah, it synchronizes files. Many people can be working on one of these at one time. It has a lot of built-in abstractions for being able to cleanly and efficiently organize groups of many people working on a single project. So you shouldn't include compiled files in Git. Yeah, I wouldn't recommend it. Generally speaking, when people are actually distributing source code of this type, when people are actually distributing programs of this type, what's generally distributed is the source code plus instructions on compilation. Sometimes instructions in compilation written in, shell script so that it can be executed automatically. So when I have when I download a package for Linux and install something on Linux, it installs itself automatically, but what it's doing is it's downloading the source code and then compiling that source code and putting the executable on my computer. So yeah, executable files are generally speaking not transferable. You can get away with it. You can get away with it, but it's not recommended. It's not the recommended way of doing it. When you commit a C file, is it common practice to git ignore the a.out file, or does that really matter? So now I have to explain what git ignore is. So if you have a git ignore file, and this is just going to confuse people, but it's a way of excluding different file types that you don't want in there. For example, when I compile the slides, when I compile my slides, I get a bunch of crap files that aren't important or in any way. They're just intermediate files that the thing generates and then doesn't delete. And so I do not include these in my Git repositories because they just waste space. So if you take a look inside of here, I have a git ignore file with all of the file types that I do not send to the repository. So yeah, and if you want to put your executables in there too, that's completely up to you. Would it be possible for us to get a copy of the code you've been working on? Well, I haven't really been working on code. The only code I was working on was that Hello World. So, that's a good point. So, the copy and paste shortcuts don't work in terminal. Like if I try to use copy and paste, yeah, it doesn't work. Control C is actually interrupt command. Yeah, so if you right click and go paste, then you can actually paste. I don't know why, but yeah. Yeah. So yeah, so that's class. Thank you very much for your time and attention today. If you have any questions, please ask them now. And otherwise we'll get on with our days, shall we? Can you get written instructions on how to push and pull assignments so that you can go back and review when you start submitting assignments? Yes, that we're actually working on preparing a tutorial document for you guys right at this very minute. Chav is working on it. So yeah, we are working on a tutorial document to get you guys like a quick start guide for getting your assignments submitted. That is in production as we speak. When is the virtual tutorial for this class, and is attendance mandatory? Attendance for tutorials is not mandatory, but strongly recommended. You're going to make me look it up. You're going to make me look it up. Virtual is Thursdays, so today, 3:30 to 4:30. Virtual, location, MS Teams. MS Teams link is in the Avenue feed. Oh, the crypto stuff, yeah. One more question about Git. Can you do the Git commands straight from PowerShell, or do you have to open up PowerShell from within a specific file on your computer? I've never really used it on PowerShell, so I don't know. I don't know. If you're in Windows, my inclination would be to use a GUI, like to use a GUI tool to do it. Can you use Docker? So just keep in mind that you're using GitLab here, not GitHub. So, yeah, I don't mind if you do use, like if you know how to use some of the higher automation stuff. I'm not going to be teaching it in this class, but if you know how to use it, then I have no problem with you using it. You know, so long as it's not having an influence on like people collaborating on your assignment or anything, right? Like, so long as it's not academic dishonesty territory, I'm fine with you using, you know, like make files and that sort of thing, or Docker. So, I've received some requests to talk briefly about Bitcoin. So, I don't have any slides on Bitcoin or anything. I can just like tell you what it is, what I know about it. So, what Bitcoin is, as far as I'm aware, is that it's a Bitcoin. A Bitcoin is a cryptographic key, right? And the cryptographic keys are quote-unquote mined, but what mining actually is it's running a gigantic distributed brute force algorithm to try to find more of these cryptographic keys, right? So when you mine a Bitcoin, you have found a cryptographic key that works, you know, according to the cryptography algorithm. So, yes. So, the way that So the way that crypto works is using a technology called blockchain. And the idea of blockchain, very roughly speaking, I'm not an expert in blockchain, but what you essentially have is a ledger that is freely available. So everybody can look at the Bitcoin ledger, right? And the Bitcoin ledger is just it's a keeping track of every single Bitcoin transaction that has ever occurred. Question, so there is a limited amount of these keys? Yes, actually true. And actually, some people would argue that that's one of the great advantages of a key, right? That's one of the great advantages of crypto, is that there's a limited amount of it. Part of the problem that we're getting into with the financial system that we currently have set up is that we're on a system called fiat currency, which means that the government basically can print as much money as it wants. If you understand currency to be a commodity, also subject to the laws of supply and demand, then the more of it there is, the less valuable it is, right? So if the government has the ability to print as much money as it likes, the incentive is that the government will do so, because that's, like the government, what disincentivizes a government from printing money for itself, right? However, like if it's linked to like a hard commodity like gold, like it used to be once back when we were on a gold standard, the government did not have the ability to the government did not have the ability to print money, so you don't run into problems with inflation, because that's what that is. That's what causes inflation to a large degree, is the supply of money becoming larger over time. If the money supply increases, then each piece of money is worth less, right? Yeah, inflation. So because Bitcoin, the total number of Bitcoins is capped, and I don't think we've mined all of the Bitcoins. I think I would have heard about it if we'd mined all of the Bitcoins. But because the total number of Bitcoins has like a fixed cap, it can't, it's not subject to the same degree of inflation, so it functions more like gold as a commodity than the US dollar as a currency. But yeah, okay, so question, what stops people from mining the same key? Well, you have to register your keys, right? So when a new key has been discovered, it has to be logged with the with the Bitcoin register. And so the thing about the Bitcoin register is that when, basically I think the way it works is any Bitcoin wallet is an instance of the entire Bitcoin register. So basically every Bitcoin transaction is freely and publicly available. You can look at all of them, but who owns what Bitcoin is completely anonymous. So it's not like you can say, oh, Fred has $3,000 in micro Bitcoin. You can't, because it's just on crypto keys. It doesn't actually match up to any person. So yeah. But yeah. So why are we finding these keys in the first place? Oh, XRP is fully mined. Oh, there you go. So that kind of gets to the question, so why even Bitcoin? Why is Bitcoin so popular? And it basically comes down to the law of economics, one of the fundamental laws of economics, which is it's worth what people will pay for it. Basically, a bunch of tech bros invented blockchain. Blockchain preceded Bitcoin. Blockchain was then used to do cryptographic, to trade cryptographic keys. It was determined that these cryptographic keys could be used as currency, hypothetically speaking, and basically, after that, an intense marketing campaign occurred to try to convince people that these cryptographic keys could be used as a currency in the future, which is where the term Bitcoin originated. It's like, this is digital currency. We're trying to set this up as a digital currency. And so they managed to convince people. Eventually, people with real money got involved. Oh, this might actually be a commodity. And then the price went, like, skyrocketed right through the roof. Like, I believe, like, the apocryphal story is that the first Bitcoin transaction was somebody paid 30,000 Bitcoin for a pizza. And if you had those 30,000 Bitcoin today, I think a Bitcoin... What is a Bitcoin even worth these days? It's got to be something on the order of like $30,000. Let's see. Let's see what the internet knows. Price of a Bitcoin. I could probably just get Brave to show me. But, holy shoot. The current price of a Bitcoin is $45,000. So, having 30,000 of these things worth $45,000, Yeah. Yeah. 60 grand in Canadian. Yeah. So, most of the reason people are interested in Bitcoin is not necessarily because of, like, Bitcoin itself or the technology, although the technology is cool. It's because you had this very, very strange market phenomenon, which allowed a bunch of, like, tech nerds to become overnight, like, millionaires and billionaires, which was, kind of an incredible one-off event in human history. Sometimes you get these, like, one-off events in human history. But, have I ever used Bitcoin? I haven't used... Or Batcoin. No, I haven't. I haven't set up the ad thing for Brave because I don't like ads. But way back, a number of years ago, my friend who was actually one of these guys who made a lot of money on Bitcoin, I was like, you know what? I'm going to buy your lunch. You pay me in Bitcoin. So he gave me like $10 in Bitcoin. And like now, however many years or later, that $10 is now worth like $150. So I can imagine if I'd have put like $5,000 into it, I would have gotten, $50,000, $75,000, something like that, minus your initial investment cost, of course. But yeah, that's pretty much everything I know about Bitcoin. Yeah. Anyway, that's about everything that I have to say today. So office hours are today, so if you want to swing by, feel free. I'll be in my office. ITB 102. Otherwise, take her easy, folks. And remember that Bitcoin investing, like investing in any volatile market, don't invest any money that you are not prepared to lose. If I've inspired any Bitcoin investors today. Take her easy, folks.